So we have made it now to level 3. Level 3 is again one of our simpler levels. It covers linear and quadratic functions. So we've seen those before. We've been working with those kind of sparingly. So what I wanted to point out to you guys is the first two chapters are linear functions and then this data functions. We're going to be using our calculators with these two. But since we've got other things coming up, like senior retreats really soon, we're going to have a mini test over these two units. Then after that, we'll have the rest of the test. So in another week or so, we'll have a test over 3.3 to 3.5, which is all about quadratics, and then we throw in inequalities afterwards. So by the end of this level, you should know, like before, with linear functions, you should know slope, intercept form, standard form, and be able to find slope. And with quadratic functions, you'll be able to find the vertex, put it in vertex form, find the axis of symmetry, and be able to recognize what standard form tells you. We're also going to be working with story problems. We're going to be using your calculator a lot so that we can analyze data. And then the last thing is quadratic inequalities. So let's jump right to it. So linear functions and their properties, level 3.1. The definition we're going to use for a linear function is going to be in slope-intercept form. So y equals mx plus b, where m is the slope and b is the y-intercept. So the nice thing about these, with linear functions, and in fact with all polynomials, the domain will always be all reals. And that's because there are no restrictions. That means there's nothing that we can't plug in to our linear function that we get a bad answer out. So example 1, graph the linear function f of x equals negative 3x plus 7. Okay, so that means, I'll give myself a little room. I go 1, 2, 3, 4, 5, 6, 7. My y-intercept is 7. My slope is negative 3 over 1. So I go up to 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Put a dot there. Then my slope is negative 3, so I go down 3 to the right 1. Much like you did in 9th grade, that's how we graph a line. We've been doing that for a while. So then call back to level 2, average rate of change of a linear function. Average rate of change, as we said before, is the delta y over delta x, or the change in y over the change in x, which is a fancy way of saying slope. So we've been doing this, and we can do this for a bunch of different functions to figure out what is the rate of change. So what does that look like looking at a table? So let's zoom in just a little bit so you can see this. How do you find the average rate of change given the table below? Well, what I want to look at is I want to look at the change from x to y, changes in the y's, like this, and I want to look at the changes in the x's. So the change in the x from 0 to 1 is 1, from 1 to 2 is 1, from 2 to 3 is 1, from 3 to 4 is 1, from 4 to 5 is 1. The change from 0.09 to 0.12, which is 0.12 minus 0.09, which is 0.03. From 0.12 to 0.16 is going up 0.04. So I should write plus 1, plus 1. These should all be pluses. From 0.16 to 0.22 is a gain of 6, so plus 0.06. From 0.22 to 0.29, that's a gain of 0.07. And from 0.29 to 0.39 is plus 0.1. So if you looked at all of the slopes here, that would be 0.03 over 1, then 0.04 over 1, then 0.06 over 1, then 0.07 over 1, and 0.1 over 1. And this is just for us. If the average rate of change is constant, which means all of these would be the same, then we have a linear function. So in A, this example is not linear because these aren't the same. If we check out B, and I zoom in just a little bit so we can read B. So my age is X, my heartbeat's Y, so my age is going up 10 each time. 50, 60 is 10. So we're going up 10 each time. And the beats per minute, from 50 to 47.5, that's down 2.5. From here, from 47.5 to 45 is down 2.5. From 45 is down 2.5. I think we start seeing the pattern. This is down 2.5, and here it's down 2.5. So if I looked at the change in y over the change in x for each one of these, I would have negative 0.25 over 10 for each one. So this function is linear because the change in y over the change of x is constant. So let's just put that into words right there. Since the change in y over change of x is constant, or the constant slope, therefore we have a linear function. All right, we flip it over, we'll finish up level 1, level 3.1. So next on the list is increasing, decreasing, or constant linear functions, and how do you tell? Well, what this means is if a function is increasing, then we have a positive slope. If our function is said to be decreasing, then we have negative slope. And if our function is said to be constant, then we have slope of 0. So those are our three cases. Either it's increasing because it has positive slope, decreasing if it's negative slope, or it's constant because the slope is 0. So let's look at a couple examples here and see if we can recognize this. So A, our slope is 5, positive 5, so this is increasing. And I'm just going to identify the slope in each one. For B, the slope is negative 2, so that is a decreasing function. For C, my slope is 3/4, so that's positive, so I have an increasing function. And for D, I have, this is really like writing 0x plus 7, so my slope is 0, so that means I am constant. And just so we remember, a constant function is just a horizontal line. So this is another way of writing a horizontal line. All right, last one, story problem. So I'm not going to read the entire thing, but this story problem is basically a book value. A book value is the value of an asset for a given company. Some companies depreciate their assets, meaning they lose money over time. The amount of the decline depends on the useful life that the company places on asset. Okay, suppose that a company just purchased a fleet of new cars for its sales force at a cost of $28,000 per car. So that was their initial cost. The company chooses to depreciate each vehicle using the straight line method over 7 years. This means that each car will depreciate $20,000, or it will depreciate $4,000 per year. So if we write a linear function that expresses the book value of each car as a function of its age. Okay. So our value, I'm just going to write value in terms of x, is equal to, well, it started out at $28,000. And each year, it loses $4,000. So that's 28,000 minus 4,000 x. That's it. So B says graph it. So I would go up, let's say this is 28,000, and my slope is, this is years, this is dollars. So my slope is negative 4,000. So my graph would look something like this. C, what's the book value after 3 years? Well, that's going to be 28,000 minus 4,000 times 3, or 28,000 minus 12. And 28 minus 12 is 16,000. For D, interpret the slope. Well, we know we have a negative slope here, or we can look at the graph and see that it's going down, so that's decreasing. And E, when will the book value of each car be 8,000? So that one I set 8,000 for our Y equals 28,000 minus 4,000 X. So here what I'm going to do is swap sides with the 8,000, so I have 4,000 X equals 28 minus 8,000, or 20,000. So 4,000 X equals 20,000, or X equals, divide both sides by 4,000, you get X equals 5. So after 5 years, we get the price that we want. All right. Good luck on these book problems. Let me know if you have any questions.